Okay, then here's the question. It's a long question, so I'll scroll through it and stop at various places. Okay, that's the question then. I've got it all summarised here. Here's a summary of the question. If you want to have a go at it first, which is ideal. The first thing is to find the inverse function f minus 1. Okay, here's f of x. So, right, so I'm going to do it over here, I think. So y is equal to ln 2x minus 3. And this is part 1. So, okay, unwrap the log. This is log e, so the e swings under and hits this in the air. And that's how we unwrap the log. So that tells us then that 2x is equal to e to the y. And move the 3 over to be plus 3. And that tells us that x is equal to, move the 2 from times to divide, so it's a e to the y over 2. Plus 3 over 2. So inverse. So swap the x to a y and the y to an x. E to the x over 2 plus 3 over 2. Apologies for squeezing it in here, but I thought it was a good idea because such a long question to just try and tidy things up by putting it in this small space. Okay, so that's e to the x over 2. Now, state the range of f minus 1. Well, x is bigger than 2/3. You can see the sketch of it here. This would be 2/3. And this is our sketch. So it's here. So the range, well, when we do the inverse, because we're going to do the sketch in a minute, this axis will flip upside down and it will just be curving up here. So it'll go from this value, which will be over here, upwards and just continue on going up. And you can see that, can't you? E to the x is positive, looking at the function. And it goes down to half, 0, because this e to the minus infinity will be 0. So this will go to 0. But the only thing is, yeah, that's fine. That's fine. And this, so it's plus 3 over 2 would be the smallest value this is capable of, isn't it? So range, I'll put it over here. Squeeze it in with the diagram. Range is equal to, okay, so it's the smallest value of 3 over 2. It's less than the x's. And it goes up to infinity, doesn't it? So x is bigger than 3 over 2. So we can write it from left to right if we wish. So it doesn't touch 3 over 2, does it? Because minus infinity is not a number. But it shoots up to infinity, so there's no upper limit to these values. So that's the range then. Part 3, sketch this indicating the y-axis crossing point. So here I'd like to draw the sketch using this existing picture and overwrite it. So basically, on our mind's eye, we pull this off the page and flip the x-axis over and put it down onto the y, and the y we turn it over and put it onto the x, and that would be the inverse function then. So instead of that line going there, it will go there, won't it? So let's do that then. It's going to come along here, and that value is the 2/3 value, and the curve will go along here, and it will go up and then just shoot up as the exponential does. And these can then go, and that's our new curve. So this would be y is equal to e to the x over 2 plus 3 over 2. When x is 0, you get a half, plus 3 over 2 is 2, so this would be the y-axis crossing point, 0, 2. So I'll indicate it here on the diagram. because it asks for this. Okay, good. So that's the sketch. Part B now. So let's move on to this. We'll go down to part B. We've got plenty of room now. Okay, g of x is that for find g of f of x. So g of f of x then. Now f of x, let's just go back and get it. Log of 2x minus 3. That's g of ln of 2x minus 3 for x is bigger than 2/3. G is equal to this, so it's equal to e to the 2 lots of this object here. This is g of something, e to the 2 times something. 2 times something minus 4. E to the 2 times something minus 4. There we go. So that's equal to then e to the ln of 2x minus 3 squared minus 4. E and the log cancel each other out, so we get 2x minus 3, because one is the inverse of the other. Minus 4. Expand this bracket, 4x squared. Oh, we'll leave it in that form, because I think that's the form that was required. So there we go. Let's have a look. As ax, so here a is equal to 2, b is equal to 3, isn't it? And c is equal to 4. And they're all integers. Write down f of g of x and solve f of g of x equals log 5. F of g of x then, part 2. F of g of x is equal to, okay, so it would be f of g of x, which is 2x e to the 2x minus 4, and f is ln 2x minus 3, so that's equal to ln of 2. X is this stuff here, that's the something, ln 2x minus 3, close bracket, which is equal to ln 2 e to the x. Minus 8 minus 3 is minus 11. And that's equal to log 5, wasn't it? Log 5. So that tells us then that 2e to the x minus 11 is equal to 5. Because the values would be the same then, won't they? Because the logs are the same. So e to the x, move the 11 over to 16. And it's 2 lots of. And then just move the 2 from times to divide. 16 over 2, which equals 8. And then take logs, both sides. X is equal to log e. Move the e down, is ln of 8. So there's x as a value. Fgx, so x is equal to log 8. Just one slight correction here. I managed to write this line down incorrectly, didn't I? Because I just decided to change the 2x here to an x for some reason. So let's just put our 2x back in here. I'm going to squeeze it in there, squeeze it in there, squeeze it in there, and squeeze it in there. So hopefully that should be clear now, shouldn't it? That's 2x, so we actually get x equals half log 8. Apologies for that. For some reason I decided to drop the 2x and write x instead of one stage along the calculation. Here.